Get comfortable. Close your eyes if you'd like, and let yourself relax as we explore the quiet history of animals that once walked, flew, and swam across our planet. Most animal species that have ever lived on Earth are now gone. It's a humbling thought. Scientists estimate that roughly 99% of all species that ever existed are now extinct. The Earth has been home to countless forms of life over billions of years, and the vast majority have faded into the fossil record, leaving only traces of their existence behind. Many of these extinct animals vanished during past mass extinctions. Earth has experienced several periods of rapid loss throughout its long history. These weren't gradual declines, but dramatic events that reshaped life on our planet. From the end of the dinosaurs 66 million years ago to earlier catastrophes we're still piecing together, our world has seen life nearly wiped clean and then slowly, patiently rebuilt. Extinction, it turns out, is a natural part of evolution. Species arise, adapt, thrive, and eventually give way to new forms of life. It's the rhythm of nature, playing out over timescales almost impossible for us to fully grasp. But in recent centuries, something has changed. Human activities have dramatically accelerated extinction. What once unfolded over millions of years now happens in mere decades. Habitat destruction, overhunting, pollution, invasive species, and climate change are the main drivers today. Forests fall to make room for cities and farmland. Animals are hunted faster than they can reproduce. Chemicals seep into ecosystems. Species are introduced to places where they don't belong, disrupting delicate balances. The climate shifts in ways that leave some creatures unable to adapt quickly enough. These forces, all connected to human expansion, have pushed countless species to the brink. When we talk about recently extinct mammals, we're usually referring to those that disappeared after about the year 1500. This time frame helps scientists track extinctions during the age of global exploration and industrial development, when human impact truly began to spread across every continent and ocean. These recently extinct animals include not only famous species, but many rodents, bats, and shrews. The well-known losses, like the dodo or the Tasmanian tiger, capture our imagination. But for every celebrated creature, there are dozens of smaller animals, less dramatic perhaps, but no less important to their ecosystems. Little mammals that crept through the underbrush or fluttered through tropical nights, now gone forever. Scientists only declare a species extinct after long, careful surveys. It's not a decision made lightly. Researchers must conduct extensive fieldwork, sometimes over many years, searching in every possible habitat where the animal might still survive. They look for tracks, droppings, calls, any sign of life. Only when all evidence suggests the species is truly gone will they make the official declaration. Because of this careful process, many species are listed as possibly extinct for decades. They linger in a state of uncertainty, neither confirmed as surviving nor officially declared lost. It's a kind of scientific limbo, a space between hope and acceptance. And sometimes hope wins. Some animals once thought extinct, like the New Zealand takahe, were later rediscovered. This large, flightless bird was believed to have vanished until a small population was found in a remote mountain valley in 1948. These rediscoveries remind us that nature can be resilient, that pockets of life can persist persist in unexpected places. But for most species, extinction is permanent. Once gone, they're gone forever. There's no bringing them back, no second chances, making each loss irreversible. Each extinction represents millions of years of evolution, unique adaptations and ecological relationships, all ending in silence. As you continue to relax, breathing slowly and deeply, let these thoughts settle gently. The story of extinction is vast, touching every corner of our planet and every era of life. And there are so many more stories to discover. Let your mind drift now, back through time, to worlds that existed long before cities, before agriculture, before humans walked upright. Worlds populated by creatures that would seem impossible if we didn't have their bones to prove they were real. Fossils show Australia was once home to giant marsupials like Diprotodons, larger than modern rhinos. Imagine that for a moment. Australia today is famous for its kangaroos and koalas, but tens of thousands of years ago, enormous marsupials grazed across the landscape. Diprotodon was the largest marsupial ever to exist, a massive herbivore that could weigh over 2,000 kilograms. Picture something like a gigantic wombat, lumbering slowly through ancient forests and grasslands, utterly unaware that one day its kind would vanish completely. Across the ocean in South America, an equally remarkable creature roamed the plains. Glyptodon, a tank-like armored relative of sloths, lived until around 10,000 years ago. This wasn't a small animal. Glyptodon was roughly the size of a small car, encased in a thick, domed shell, made of bony plates fused together. Its tail was often tipped with spikes, a club-like weapon for defense. When you looked at a Glyptodon, you weren't seeing a prey animal. You were seeing something built like a fortress, something that had evolved to withstand almost anything the prehistoric world could throw at it. And yet, even armor couldn't protect it from extinction. Then there were the predators. Saber-toothed cats such as Smilodon had upper canine teeth up to 18 centimeters long. 18 centimeters. That's roughly 7 inches of tooth protruding from the jaw, curved like daggers. These weren't teeth for chewing. They were precision instruments for killing. Smilodon likely used those massive canines to deliver devastating bites to the throats of large prey, severing major blood vessels. The cat would have needed an incredibly strong neck and skull to wield such weapons effectively. Close your eyes and picture it. A powerful, muscular predator stalking through the twilight, those extraordinary teeth gleaming. But teeth came in all forms. Some prehistoric amphibians had thousands of tiny hook-like teeth to grip slippery prey, while Smilodon went for power and penetration. These ancient amphibians took a different approach. Their mouths were lined with countless small, backward curving teeth that worked like Velcro. Once prey entered their jaws, there was no escape. Fish, other amphibians, anything that swam into range would be caught and held tight. It was an elegant solution to a difficult problem. How do you hold on to something wet and writhing? Life found endless ways to adapt. The prehistoric dolphin, Inomorostrum xenos, had a short, toothless snout and fed by suction. Unlike modern dolphins with their arrays of sharp teeth, this ancient marine mammal had evolved a completely different feeding strategy. It would swim close to the seafloor, using powerful suction to pull small fish and invertebrates directly into its mouth. No teeth needed, no chase required, just the simple physics of pressure and flow. It's a reminder that evolution doesn't follow a single path. Different creatures facing similar challenges often find wonderfully different solutions. And then there are the woolly mammoths. Many woolly mammoths lived during the last ice age, that long period of cold that gripped much of the northern hemisphere. These magnificent creatures were perfectly adapted to frigid environments. They had thick fur, sometimes over 30 centimeters long, a layer of fat beneath their skin for insulation, and small ears to minimize heat loss. They use their curved tusks to sweep away snow and reach the vegetation beneath. Herds of mammoths moved across icy landscapes that would seem utterly inhospitable to us, thriving where few other large animals could survive. Mammoths often died in cold regions and became trapped in ice. Sometimes they fell through thin ice covering rivers or lakes. Sometimes they were caught in sudden storms or avalanches. Whatever the cause, the freezing conditions that killed them also preserved them in ways almost nothing else could. Ice preserved their hair, skin, and stomach contents. Think about what that means. These animals died thousands of years ago, yet when their frozen bodies are discovered today, they can still have fur attached, skin intact, organs recognizable. Even the partially digested food in their stomachs remains, telling us exactly what they ate in their final hours. It's as close as we can come to traveling back in time. These frozen remains allow scientists to study mammoths in great detail. Researchers have extracted DNA from mammoth tissue, analyzed the structure of their hair under microscopes, studied diseases they suffered from, even identified the specific plants they preferred to eat. Some mammoth remains are so well preserved that scientists have considered whether it might be possible to clone them, to bring mammoths back from extinction. Whether we should is another question entirely, but the quality of preservation makes it at least theoretically possible. Prehistoric life was often far stranger and larger than what exists today. The animals we've just explored are only a tiny sample. There were birds taller than humans, insects the size of seagulls, snakes that could swallow crocodiles, fish armored like submarines. The past was populated by experiments in body design that succeeded for millions of years before circumstances changed and they faded away. Our modern world is, in many ways, a quieter, smaller place than what came before. As you relax deeper into comfort, let these images drift through your mind. Giant marsupials grazing, armored glyptodons plodding slowly, smilodon prowling, mammoths trudging through snow, all of them real, all of them gone, all of them part of Earth's long, long story. Breathe slowly and let your thoughts drift to islands. Small worlds surrounded by ocean, isolated from continents, where evolution follows different rules, where safety can become a kind of trap. Many extinct island animals evolved flightlessness because they originally had no predators. Picture what that means. On a remote island, a bird arrives, carried by storm winds perhaps, and finds abundant food, pleasant climate, no foxes, no cats, no snakes, nothing that wants to eat it. Generation after generation, the birds that spend less energy on flight, that build heavier bodies, better suited for walking and foraging on the ground, do just as well as their flying cousins. Better, even, because they can grow larger, store more fat, raise more chicks. Over thousands of years, wings shrink, flight muscles diminish, the birds become walkers, runners, creatures perfectly adapted to a world without danger from above or below. This later made them extremely vulnerable to humans and introduced animals. When people arrived on these islands, often bringing rats, pigs, dogs and cats with them, the flightless birds had no evolutionary experience with predators, no instinct to flee, no ability to escape to the treetops. They would simply stand and watch as danger approached, confused, unafraid, defenseless. It was a tragedy written in evolutionary ink, the adaptation that had been perfect for millions of years, suddenly rendered fatal in mere decades. The elephant birds of Madagascar stood about 3 meters tall and laid the largest eggs ever known. Imagine standing next to one. You would barely reach its chest. These were birds that had evolved into the ecological role that large mammals filled elsewhere, grazing on vegetation, dominating the landscape through sheer size. Their eggs were extraordinary, some measuring over 30 centimeters in length and holding nearly 10 liters of fluid. A single elephant bird egg had the volume of about 150 chicken eggs. They were monuments to the possibility of avian gigantism, proof that birds, given the right circumstances, could rival any mammal in size. Madagascar was full of wonders. The Madagascan dwarf hippopotamus survived until roughly the last 500 years, while Africa had, and still has, large hippopotamuses. Madagascar's version had shrunk over countless generations. It was a compact creature, perhaps the size of a large pig, that spent its time in rivers and marshes, living much as its larger relatives did, but in miniature. When humans arrived on Madagascar around 2,000 years ago, they found an island filled with unique creatures that existed nowhere else on Earth. Many of them, including the dwarf hippo, didn't survive the encounter. This shrinking process had a name. Large mainland animals often evolved into smaller island forms, a process called island dwarfism. Resources on islands are limited. There's only so much food, so much space. Large animals that arrive or evolve on islands face evolutionary pressure to become more efficient, to need less food, to reproduce successfully in a confined area. Over time, their descendants grow smaller and smaller, until you have hippos the size of pigs, elephants the size of ponies, deer that could fit in your living room. The Cyprus dwarf elephant stood only about 1 meter tall. That's roughly the height of a large dog. These tiny elephants evolved from full-sized ancestors that somehow reached Cyprus hundreds of thousands of years ago, perhaps swimming between islands during ice ages when sea levels were lower. On Cyprus, with limited vegetation and no predators, smaller elephants survived better. They needed less food. They could navigate the rocky terrain more easily. Generation by generation, they shrank until you had elephants that weighed perhaps 200 kilograms instead of several thousand. Imagine encountering one. All the features of an elephant, the trunk, the tusks, the wise eyes, but compressed into a body barely waist high. It vanished roughly 12,000 years ago after humans arrived on the island. The timing is rarely coincidental. Across the world, on island after island, the arrival of humans coincides closely with the disappearance of unique species. Sometimes the evidence points to hunting, sometimes to habitat destruction as forests were cleared for farming, sometimes to fires, either accidental or intentional, that swept across islands and eliminated the plants these animals depended on. The dwarf elephant left behind bones, fossils, fragments of a world that once was and can never be again. Several mascarene giant tortoises were wiped out by sailors harvesting them for meat. The Mascarene Islands, Mauritius, Réunion, and Rodriguez, scattered in the Indian Ocean, were home to enormous tortoises that had no fear of humans. When ships began stopping at these islands in the 16th and 17th centuries, sailors discovered these tortoises were easy to catch and could survive for months in ship holds without food or water, providing fresh meat on long voyages. Thousands upon thousands were loaded onto ships. Some species were eaten into extinction within a few decades of being discovered by Europeans. The tortoises couldn't hide, couldn't flee, couldn't reproduce fast enough to replace their losses. But direct hunting wasn't the only threat. Introduced pigs and rats also destroyed tortoise eggs. Pigs, left on islands by sailors to establish breeding populations for future meat supplies, would root through beaches and forest floors, finding tortoise nests and devouring the eggs. Rats, which escaped from ships or were deliberately released, multiplied rapidly and developed a taste for tortoise hatchlings and eggs. Even if adult tortoises survived, their reproduction was sabotaged. No eggs meant no babies, and no babies meant a slow, inevitable slide toward extinction as the remaining adults aged and died, with no new generation to replace them. Island ecosystems are among the most fragile on Earth. They evolved in isolation, with fewer species filling each ecological role, with tighter connections between plants and animals, with less redundancy to buffer against loss. Remove one species and others can collapse like dominoes. Add one invasive species and it can tear through the ecosystem like wildfire. Islands are laboratories of evolution, producing remarkable diversity, but that same isolation that allows uniqueness also creates vulnerability. What thrives in isolation can perish when that isolation ends. Let your breathing slow. Feel yourself sinking deeper into rest. These islands exist still, of course, scattered across the world's oceans, but they're quieter now, emptier. The giant birds don't stride across Madagascar. The dwarf elephants don't browse in Cyprus. The tortoises don't crawl slowly across Mauritian beaches. The islands remain, beautiful and green, but something essential has been lost, something that can never return. Settle deeper now. Let the weight of your body sink into softness. We turn to stories that are harder to hear, but important to remember. Stories of abundance meeting appetite, of curiosity meeting carelessness. The Réunion giant tortoise was once so numerous that ships loaded hundreds at a time. Imagine the beaches of Réunion Island, that volcanic speck in the Indian Ocean, crawling with these massive ancient creatures. They moved slowly, unbothered, grazing on island vegetation, living their patient lives. When European ships began arriving in the 16th century, sailors saw not wildlife, but provisions. The tortoises were easy to catch, could be stacked in ship holds alive, and would stay fresh for months without food or water. Hundreds at a time were carried away. Ships would stop specifically to harvest tortoises, filling their holds until they could carry no more. It was efficient. It was practical. It was devastating. The Rodriguez blue pigeon disappeared in the late 1700s due to hunting and deforestation. This wasn't a subtle fade into rarity. It was a relatively quick collapse. The pigeon was beautiful, with plumage in shades of blue and white, and it lived only on Rodriguez, another small island in that same scattered archipelago. As settlers arrived and cleared forests to create farmland, the pigeons lost their habitat. The trees they nested in fell. The fruits they fed on vanished. And while their world shrank, hunters shot them for food. By the time anyone thought to document them carefully, to study them, to perhaps protect them, they were already gone. The last confirmed sighting was sometime around the 1780s. After that, silence. The King Island emu vanished within decades of European arrival. King Island lies in the Bass Strait between Tasmania and mainland Australia, a windswept place that was home to its own subspecies of emu. These birds were smaller than mainland emus, adapted to island life, and they had survived for thousands of years in isolation. Then Europeans arrived in the early 1800s, bringing livestock, clearing land, and hunting the emus both for food and because they competed with domestic animals for resources. Within just 30 or 40 years, the King Island emu was extinct, a lineage that had persisted through ice ages and climate shifts couldn't survive a few decades of human settlement. Perhaps no extinct animal is more famous than the next one. The dodo went extinct in the late 1600s after heavy hunting. This large, flightless bird lived only on Mauritius, and when Dutch sailors arrived in the late 1500s, they found an animal that had no fear, no escape strategy, no defense. The dodo waddled around, curious and approachable, and was easily clubbed to death. Sailors killed them in large numbers, salted the meat, and carried it away. Contemporary accounts describe the dodo as not particularly tasty, but when you're on a long sea voyage, fresh meat is fresh meat. But hunting alone didn't doom the dodo. Introduced pigs and rats destroyed dodo nests. The dodo nested on the ground, laying a single egg at a time. With no native land predators on Mauritius, this strategy had worked perfectly for eons. But pigs brought by settlers would root through the forest floor, finding nests and eating eggs. Rats multiplied rapidly and did the same. Even if adult dodos survived, they couldn't reproduce successfully. Their numbers dwindled year by year until sometime around 1660 or 1670, the last dodo died. We don't know exactly when. No one was paying attention. By the time people realized the dodo was gone, it had already passed into legend and metaphor, a symbol of extinction itself. Far to the south, in a cold and windswept place, another unique creature faced its end. The Falkland Islands wolf was the only native land mammal of the Falklands. Think about that. These remote islands in the South Atlantic, buffeted by constant winds, surrounded by frigid ocean, somehow became home to a wolf unlike any other. It was a medium-sized canid, probably related to South American foxes, though how it reached the Falklands remains a mystery. Some scientists think it walked across a land bridge during ice ages when sea levels were much lower. Others suggest it might have swum or been carried on ice floes. However it arrived, it had the islands to itself for thousands of years. It was hunted to extinction by settlers by the late 1800s. When people began arriving in the Falklands, they brought sheep and other livestock. The wolves, curious and fearless like so many island animals, would sometimes kill sheep. Settlers responded by poisoning, shooting, and trapping the wolves. The animals made it easy. They had no fear of humans. They would approach people directly, sometimes even coming when called. This trust made them incredibly easy to kill. Someone noticed what was happening and understood what it meant. Charles Darwin predicted humans would wipe it out. During his voyage on the Beagle in 1833, Darwin visited the Falklands and observed these unique wolves. He noted their tameness, their lack of fear, and he wrote with remarkable clarity that this behavior would lead to their destruction. He understood that an animal without fear of humans, in a world increasingly dominated by humans, was doomed. His prediction proved correct. By 1876, the Falkland Islands wolf was extinct. The last known individual was killed on West Falkland Island. Darwin had been right. It wasn't a difficult prediction, really. The pattern was already well established by then. Humans arrive. Unique animals disappear. Again and again, on island after island. The story repeated itself with minor variations, but the same ending. Human expansion repeatedly triggered sudden animal losses. Not gradual declines over millennia, but collapses measured in decades or even years. Species that had survived ice ages, volcanic eruptions, hurricanes, and countless other natural challenges couldn't survive contact with human civilization. The losses came quickly, often before scientists even had a chance to study the animals properly, to sketch them, to understand their behavior, to document what was being lost. Rest now, breathe slowly. These stories are heavy, but they're part of the larger story, the one we're exploring together through the quiet night. The Reunion beaches empty of tortoises, the Rodriguez forests silent of blue pigeons, King Island without its emus, Mauritius without its dodos, the Falklands without its wolf. Each loss is permanent, but remembering them, knowing they existed, matters. It keeps them from being forgotten entirely. Let sleep come gently as it will. There are more stories ahead, waiting in the darkness, waiting to be told. Close your eyes and imagine looking up at the sky on a clear autumn day in the early 1800s. You're standing in a field somewhere in the American Midwest, and you hear something, a sound like distant thunder, growing louder. You look up, and the sky itself seems to be moving. The passenger pigeon once numbered in the billions across North America. Not millions, billions, with a B. This wasn't a rare bird, or even a common one. It was perhaps the most abundant bird species on the entire planet. Estimates suggest there may have been 3 to 5 billion passenger pigeons living in North America before European colonization. They moved in flocks so enormous that comprehending their size requires us to abandon our modern understanding of what a flock of birds looks like. Its flocks were so massive they could darken the sky for hours. Eyewitness accounts from the 1800s describe flocks passing overhead continuously from morning until night. One ornithologist, Alexander Wilson, estimated a single flock he observed in 1810 contained over 2 billion birds. John James Audubon described watching passenger pigeons fly overhead for 3 consecutive days, the sky constantly filled with birds, their wings creating a sound like a gale-force wind. The sun would dim. The temperature would drop slightly from the shade of their bodies. Their droppings would fall like snow, coating the ground below. It must have been one of the great natural spectacles on Earth, something that inspired awe and wonder in everyone who witnessed it. The birds nested in vast colonies, sometimes covering hundreds of square miles of forest. Trees would break under the weight of the nests and the birds themselves. They fed primarily on nuts, acorns, and seeds, descending on forests in numbers so great they would strip trees bare in hours. They were beautiful birds, with blue-grey backs, rosy breasts, and iridescent necks that shimmered in the sunlight. They flew fast, possibly reaching speeds of 60 miles per hour, and despite their massive numbers, or perhaps because of them, they were remarkably trusting around humans. Hunting and habitat loss caused its rapid collapse. Native Americans had hunted passenger pigeons for thousands of years, taking what they needed but making no noticeable dent in the population. But when European settlers arrived, the scale changed dramatically. Commercial hunting operations developed, targeting the massive nesting colonies. Hunters would arrive at colonies with wagons, clubs, nets, and guns. They killed birds by the tens of thousands, packed them in barrels, and shipped them to city markets where they were sold cheaply as meat for the poor. Entire trainloads of dead passenger pigeons left nesting sites daily during a peak hunting season. At the same time, the vast eastern forests were being cleared for farmland. The mature trees that produced the acorns and nuts the pigeons depended on were falling. Their nesting habitat was shrinking. Their food supply was diminishing. The birds needed enormous flocks to survive. Their breeding success was linked to their massive colonies. And as their numbers began to drop, they may have fallen below some critical threshold where reproduction couldn't keep pace with mortality. By 1914, the passenger pigeon was extinct. The decline was shockingly fast. In the 1870s and 80s, they were still abundant, though noticeably reduced. By the 1890s, they were rare. By 1900, sightings had almost ceased. The last confirmed wild passenger pigeon was shot in 1901. A few dozen survived in captivity, but they didn't breed successfully. The last living passenger pigeon was a female named Martha, who lived at the Cincinnati Zoo. She died on September 1st, 1914, at about 1 p.m. Her body was frozen in ice and sent to the Smithsonian Institution, where it remains today. From billions to zero in less than a century. The skies, once darkened by their passage, grew empty and stayed empty. But the passenger pigeon wasn't the only loss in American skies. The Carolina parakeet was the only native parrot in the eastern United States. Imagine parakeets, bright and colourful, flying through the forests of Ohio, Kentucky, Carolinas. They were small birds, about 12 inches long, with mostly green plumage, yellow heads, and orange faces. They lived in flocks, nested in hollow trees, and fed on seeds, fruits, and nuts. They were social and noisy, filling the air with their calls as they moved through the forest. In winter, they would huddle together in tree cavities, sometimes dozens of birds packed tightly for warmth. It was hunted as an agricultural pest, As forests were cleared and farms expanded, Carolina parakeets developed a taste for cultivated crops, especially grain and fruit. Farmers saw them as pests and shot them by the hundreds. The birds made themselves easy targets. They had a behavioral trait that sealed their fate. When one bird in a flock was shot, the others wouldn't flee. They would circle back, calling, checking on their fallen companion. Hunters exploited this ruthlessly, shooting bird after bird as the flock refused to abandon their dead. Demand for its colourful feathers also contributed to its extinction. In the late 1800s, there was a fashion trend for decorating women's hats with feathers and even entire stuffed birds. The Carolina parakeet, with its vibrant plumage, was a popular choice. Milliners paid hunters for specimens, and thousands of parakeets were killed to supply the hat trade. Between agricultural persecution and fashion demands, the bird never stood a chance. The last confirmed wild Carolina parakeet was probably killed in Florida in the early 1900s. A few survived in captivity, including a pair at the Cincinnati Zoo, the same zoo where Martha the passenger pigeon died. The male, named Incas, died in 1917. His mate, Lady Jane, died in 1918, within a year of losing her companion. The species was gone, and there was another bird, less colourful, but no less important. The heath hen was a grouse native to New England. It was a chicken-sized bird that lived in coastal heathlands and open scrubby areas. In colonial times, heath hens were so abundant, they were served to servants and prisoners, considered too common for wealthy tables. They were easy to hunt and good eating. As the population grew and more land was settled, heath hen numbers declined steadily. Fires, predators, and farming reduced its population. Their preferred habitat was often deliberately burned to clear land. Domestic cats, rats, and other introduced predators killed eggs and chicks. Farms replaced the open heathlands where they thrived. By the mid-1800s, heath hens had disappeared from the mainland, surviving only on Martha's Vineyard, an island off Massachusetts. Conservationists tried to protect them, creating what may have been America's first wildlife refuge. For a while, it seemed to work. The population on Martha's Vineyard recovered to about 2,000 birds by 1916. Then disaster struck. A fire swept across the refuge that spring, destroying nests and killing birds. The following winter was unusually harsh. A disease outbreak, possibly spread by domestic poultry, killed many of the survivors. Predatory goshawks moved onto the island and preyed on the remaining birds. By the 1920s, only a handful remained. The last heath hen died in 1932. His name was Booming Ben, called that because of the male heath hen's distinctive booming mating call. Observers watched him return year after year to traditional display grounds, performing his courtship rituals alone, calling for a mate that would never come. He was last seen on March 11th, 1932, near West Tisbury on Martha's Vineyard. After that, silence. No more booming calls echoed across the heath. 3 birds, 3 stories, 3 endings. The sky that once went dark with passenger pigeons, the forests that once rang with parakeet calls, the heathlands that once echoed with the boom of displaying grouse. All gone, all within living memory of people who might have been your great-grandparents. These aren't ancient losses buried in deep time. These are modern extinctions happening in the era of photography, of recorded sound, of scientific study. We know exactly what we lost. We have specimens in museums, photographs, recordings, detailed descriptions, and still we couldn't save them. Rest now. Let your breathing slow and deepen. Feel the quiet around you, the stillness of this moment. The skies are different now than they were 200 years ago. Emptier, quieter, but the memory of what they once held can still move us, can still matter, can still shape how we move forward. Let yourself drift now, out from the land and into the water. The ocean, vast and deep, has its own stories of loss, stories of creatures that lived in the waves, that never knew the touch of soil or grass, and that disappeared into the depths forever. Stella's sea cow was a huge marine mammal related to manatees. Imagine a manatee, but enormous, gentle, slow-moving. Stella's sea cow lived in the cold waters around the Commander Islands and the coast of Kamchatka in the far North Pacific. It had thick, dark skin, often described as looking like bark. It had no teeth, only hard plates in its mouth for grinding the kelp it fed on. It spent its days floating in shallow bays, grazing peacefully on seaweed forests, coming up occasionally to breathe with a sound like a horse snorting. It reached about 9 meters in length and weighed up to 10 tons. Picture something 30 feet long, weighing as much as several cars, drifting calmly through frigid water. These were among the largest animals in their ecosystem, and yet they were completely peaceful herbivores. They lived in small family groups, showing care for one another. When one was harpooned, others would reportedly try to help it, approaching the wounded animal, attempting to dislodge the harpoon. This compassion, this loyalty to their group, made them easier to hunt. Once one was caught, others would come close, and hunters could kill multiple animals from a single group. It was hunted to extinction less than 30 years after its discovery in 1741. Georg Wilhelm Steller, the naturalist on Vitus Bering's expedition, was the first European to document the species, describing them in detail during the winter of 1741 to 1742, when his ship was wrecked on Bering Island. He noted how docile they were, how easy to approach, how their meat was delicious, and their fat useful. Word spread. Hunters, fur traders, and seal hunters began stopping at the islands to harvest sea cows for food. The animals couldn't dive into deep water to escape. They couldn't swim fast. They had to stay in shallow kelp beds to feed. By 1768, just 27 years after Steller described them, they were gone, completely extinct. An entire species eliminated in less than a human generation. The great auk was a flightless seabird of the North Atlantic. If you saw one, you might think it resembled a penguin, with its upright posture, black and white plumage, and inability to fly. But great auks were not penguins. They were alcids, related to puffins and razorbills, and they lived in the cold waters of the North Atlantic, from Canada to Greenland to Iceland to the British Isles. They were excellent swimmers, using their wings to fly underwater in pursuit of fish. They nested on rocky islands, gathering in colonies during breeding season, laying a single egg on bare rock. It was hunted for meat, oil, and feathers. For centuries, perhaps millennia, fishermen and sailors killed great auks for food. The birds were easy to catch on land, waddling slowly on their short legs, unable to escape into the air. During breeding season, entire colonies could be slaughtered. Sailors would drive hundreds of birds up wooden planks onto their ships, clubbing them to death, then rendering their fat for oil. The feathers were harvested for stuffing mattresses and pillows. As fishing expanded in the North Atlantic during the 17 and 1800s, the pressure on great auk populations increased. Colonies that had once numbered in the thousands dwindled to hundreds, then dozens. The last known great auk pair was killed in 1844 on Eldey Island, Iceland. Two fishermen, hired by a collector who wanted specimens, found the last breeding pair and their egg on a rocky ledge. They strangled the adults and crushed the egg, which was already cracked. Those two birds were the last confirmed great auks. There were scattered, unconfirmed sightings after that. Wishful thinking, perhaps, but no solid evidence. The great auk, which had survived ice ages and dramatic climate changes, couldn't survive human exploitation. The great AOK was heavily exploited as a food source. It's worth emphasizing this. These weren't birds killed accidentally or as bycatch. They were deliberately targeted year after year, century after century, because they were useful to humans. Their inability to fly, which had been an evolutionary advantage in their oceanic lifestyle, making them more efficient swimmers, became a fatal liability once humans arrived in their habitat. They couldn't escape. They couldn't adapt fast enough, and so they vanished. Across the Pacific, another marine mammal faced similar pressures. The Japanese sea lion vanished by the 1970s due to commercial hunting. These sea lions lived around the coasts of Japan, Korea, and possibly parts of Russia. They were large animals, with males reaching over 2 meters in length and weighing several hundred kilograms. They hauled out on rocky shores and small islands, breeding in colonies during the summer. Fishermen hunted them for their skin, which was made into leather, and for their organs, which were used in traditional medicine. Their whiskers were made into tobacco pipe cleaners, considered a luxury item. During the 20th century, hunting intensified. The Japanese government even paid bounties for killing sea lions, considering them pests that damaged fishing gear and competed for fish. Thousands were killed. Their rookeries were disturbed repeatedly. By the 1950s, sightings were rare. By the 1970s, they had effectively disappeared. A few unconfirmed reports trickled in over the following decades, but no solid evidence of surviving populations was ever found. The species is now considered extinct, though officially it's still listed as critically endangered because absolute proof of extinction is difficult to obtain for marine mammals. In the warm waters of the Caribbean, another seal met a similar fate. Caribbean monk seals were hunted for blubber and meat for centuries. These seals were the only seal species native to the Caribbean, and they were abundant when Europeans first arrived. Christopher Columbus noted them during his voyages. Early colonists and sailors hunted them extensively. The seals were trusting, often coming onto beaches in large numbers to rest and breed. They were easy to kill. Their blubber was rendered into oil for lamps. Their meat fed crews. Their skins were made into leather. The hunting never really stopped, even as their numbers declined, even as they became rock. The killing continued. Fishermen blamed them for eating fish and damaging nets, and killed them on sight. By the early 1900s, Caribbean monk seals were very rare, found only in isolated locations. The last confirmed sighting was in 1952, when a small group was seen between Jamaica and Nicaragua. After that, decades of silence. They were officially declared extinct in 2008. For over 50 years, scientists searched, hoping to find a surviving population, but none was ever found. The Caribbean monk seal became the first seal species to go extinct due to human causes. Its tropical cousins, the Hawaiian and Mediterranean monk seals, both remain critically endangered, struggling to avoid the same fate. These waters, once so full of life, once home to enormous sea cows grazing peacefully, great orcas diving for fish, sea lions hauling out on rocky shores, monk seals basking on Caribbean beaches, are quieter now. The losses happened gradually enough that each generation grew up thinking the ocean they knew was normal, not realizing what had been there before, not understanding the emptiness they'd inherited. Breathe slowly. Feel the rise and fall of your chest, like waves on a shore. The ocean continues, vast and seemingly eternal, but it's not unchanging. It remembers what it has lost, encoded in the absence of species that once filled ecological roles now vacant. We remember them too, or try to, speaking their names into the darkness, keeping them from being forgotten entirely. Rest now. Let the sound of distant waves, real or imagined, carry you deeper into sleep. The sea keeps its secrets, but some stories deserve to be told again and again until we learn what they're trying to teach us. Let your mind flow now, like water finding its path, away from the vast oceans and towards smaller waters, rivers that wind through continents, lakes that mirror the sky, wetlands where water and land blur together. These freshwater places, so essential to life, have their own catalogue of loss. The Baiji, or Yangtze River dolphin, was declared functionally extinct after surveys in 2006. Functionally extinct is a careful term scientists use when a species might technically have a few individuals left, but too few to sustain a breeding population, too few to recover. In 2006, an extensive survey expedition travelled the entire length of the Yangtze River, using visual observation and acoustic monitoring to search for any remaining Baiji. They found none. Not a single dolphin, not a single whistle or echolocation click. The river, over 6,000 kilometers long, seemed utterly empty of the creatures that had lived there for millions of years. The Baiji was remarkable. It was called the goddess of the Yangtze in Chinese folklore, considered a symbol of peace and prosperity. These were small dolphins, about 2 meters long, with pale grey skin, and long, narrow beaks filled with small teeth for catching fish. Their eyes were tiny, almost vestigial, because the Yangtze's murky waters made vision nearly useless. Instead, they relied on echolocation, sending out clicks and listening for the echoes, navigating and hunting in complete darkness through sound alone. It was the first cetacean driven extinct by human activity, the first whale or dolphin that we know humans eliminated. That's a significant marker, a grim milestone. Whales and dolphins, cetaceans, have existed for about 50 million years, surviving dramatic climate changes, shifts in ocean chemistry, and natural catastrophes. But they couldn't survive what happened to the Yangtze River in the late 20th century. Industrial shipping, pollution, and dam construction caused its collapse. The Yangtze is one of the world's busiest rivers, a major shipping artery for China's economy. The noise from ships disrupted the Baiji's echolocation, essentially blinding them in their already dark world. They were struck by boats, their bodies found mangled by propellers. Fishing operations using rolling hooks and illegal electric fishing methods killed them as bycatch. Chemical pollution poisoned their food supply and weakened their immune systems. And dams, especially the massive Three Gorges Dam, fragmented their habitat, preventing dolphins in different sections of the river from breeding with each other, isolating already small populations. The Baiji's extinction highlights how vulnerable freshwater dolphins are. There are only a few species of river dolphins in the world, found in rivers in South America and Asia. All of them are endangered or critically endangered. Freshwater environments are under immense pressure from human development. Rivers are dammed for hydroelectric power, diverted for irrigation, polluted by industry and agriculture, and heavily trafficked by boats. For a large aquatic mammal that needs clean water, abundant fish, and quiet conditions to hunt, these rivers have become nearly uninhabitable. The Baiji was the first to disappear, but it might not be the last. Smaller creatures face their own pressures. The Tecopa pupfish survived in water over 40 degrees Celsius. That's over 100 degrees Fahrenheit, hot enough that you couldn't comfortably hold your hand in it. These tiny fish, just a few centimeters long, lived in hot springs near Tecopa, California, in the Mojave Desert. The water came up from deep underground, heated by geothermal energy, creating small pools that were essentially warm baths in the middle of the desert. The pupfish had evolved to thrive in these extreme conditions, where few other fish could survive. Tourism and development altered its hot spring habitat. In the mid-20th century, the hot springs became a tourist attraction. Bathhouses were built, the springs were channeled into, concrete pools for people to soak in. The water flow was altered. The natural spring pools where the pupfish lived were modified, combined, and degraded. Introduced species were released into the waters. The delicate thermal balance that the pupfish depended on was disrupted. The species went extinct as a result. By the early 1970s, the Tecopa pupfish was gone. The last individuals were seen in 1970, though the species wasn't officially declared extinct until 1981. It became the first species to be delisted from the Endangered Species Act due to extinction. A tiny fish that had survived in boiling desert springs for thousands of years couldn't survive a few decades of human modification to its habitat. Halfway around the world, on an island where evolution had followed its own peculiar path, another specialist was struggling. The Alaotra grebe lived only on Madagascar's Lake Alaotra. This was a small water bird, a grebe, which are diving birds adapted for life on water. They have lobed toes instead of webbed feet, and they're clumsy on land but graceful swimmers. The Elaultra grebe was unique to this one lake, found nowhere else on Earth. It had evolved there over countless generations, adapting to the lake's specific conditions. The grebe nested in floating vegetation, built small platforms of reeds where it laid its eggs. It fed on small fish and aquatic insects, diving underwater to catch them. It had striking red eyes and subtle plumage in shades of grey and brown. Like many grebes, it was rarely seen flying. It preferred to escape danger by diving rather than taking to the air. Invasive fish destroyed its food supply. In the mid-20th century, several species of carnivorous fish were introduced to Lake Elaultra, partly to support a fishing industry, partly without much thought to the consequences. These introduced fish, species that hadn't evolved alongside the grebe, began eating the same small fish and invertebrates the grebes depended on. They also ate grebe chicks and eggs when they could reach them. The competition was too much. Nylon gill nets, used by fishermen, also trapped and drowned grebes. Pollution from nearby agriculture degraded water quality. The lake's marshes were drained for rice farming, eliminating nesting habitat. One pressure after another, building, accumulating. The grebe disappeared by 2010. The last confirmed sighting was in 1985, though there were occasional unconfirmed reports through the 1990s. By the early 2000s, extensive searches found nothing. In 2010, the species was officially declared extinct. Lake Elaultra still exists, still has water birds, still has fish, but the unique grebe that lived nowhere else is gone forever. Freshwater habitats cover less than 1% of Earth's surface, but they're home to a disproportionately large number of species, and they're among the most threatened ecosystems on the planet. Rivers are dammed, diverted, and drained. Lakes are polluted, overfished, and filled with invasive species. Wetlands are converted to farmland or filled in for development. The creatures that depend on these places have nowhere else to go. When a river dolphin loses its river, when a pupfish loses its spring, when a grebe loses its lake, that's the end of the line. Let your breathing deepen. Feel yourself sinking into rest, like sediment settling slowly to the bottom of a still pond. These freshwater places, though smaller than oceans, are no less important. They're threads of life running through the landscape. And when we pull those threads, entire tapestries can unravel. The Yangtze flows on, but without its dolphin. The hot springs still bubble up in the Mojave, but without their pupfish. Lake Elaultra still reflects the Madagascar sky, but without the red-eyed grebe diving beneath its surface. The water remembers, even if we forget. Rest now, and let these quiet waters carry you deeper into sleep. Journey now to the southern hemisphere, to ancient lands that drifted in isolation for millions of years. Australia and New Zealand, separated from other continents, where evolution created animals found nowhere else on Earth, and where the arrival of Europeans brought changes so rapid, so devastating, that dozens of unique species vanished within just a few generations. The Thylacine, or Tasmanian tiger, was a striped carnivorous marsupial. Perhaps no extinct animal captures the imagination quite like the thylacine. It looked like no other creature, a strange blend of characteristics that seemed borrowed from different animals. It had a dog-like head, a stiff tail like a kangaroo, and dark stripes across its back and rump like a tiger. But it was a marsupial, carrying its young in a pouch like a kangaroo or koala. Males even had a pouch, something unusual in the marsupial world. The thylacine was a top predator in Tasmania, hunting wallabies, possums and birds. It could open its jaws remarkably wide, nearly 120 degrees, giving it an enormous gape for its body size. It moved with a strange, stiff-legged gait, almost mechanical looking. When excited or stressed, it would stand on its hind legs and hop, or emit a series of coughing barks. There's footage of the last captive thylacine, grainy black and white film from the 1930s, showing this strange, beautiful creature pacing in its concrete enclosure. And it's haunting to watch, knowing what was about to be lost. Farmers and government bounty schemes targeted the species. When European settlers brought sheep to Tasmania, they blamed the thylacine for livestock losses. In reality, thylacines probably killed very few sheep, with most losses due to feral dogs, disease, and harsh weather. But the thylacine became the scapegoat. Starting in 1830, the government placed a bounty on thylacines. You could earn money for every thylacine you killed, just by bringing in the carcass or certain body parts as proof. Thousands were killed. Hunting parties tracked them down. Traps and snares were set throughout the Tasmanian wilderness. The last known thylacine died in captivity in 1936. His name was Benjamin, though we only call him that retroactively. He wasn't named during his lifetime. He lived at the Hobart Zoo, the last of his kind. On September 7, 1936, he died, apparently from exposure after being locked out of his shelter during cold weather. No one realized he was the very last one until it was too late. There were scattered, unconfirmed sightings in the wilderness for decades afterward, and some people still hope a population survived in Tasmania's remote forests. But no solid evidence has emerged. The thylacine is almost certainly gone. Australia lost many other unique creatures. The pig-footed bandicoot had unusual hoof-like feet. Most bandicoots have claws for digging, but this species had evolved something different. Its feet were slender with reduced toes, almost like tiny hooves, an adaptation for moving quickly across hard ground in the arid interior. It was a small, delicate creature, about the size of a kitten, with soft grey-brown fur and long ears. It lived in burrows and fed on insects, seeds, and plant material. Habitat change and introduced predators drove it extinct. As Australia was settled, the land changed. Grazing by sheep and cattle altered the vegetation. Aboriginal burning practices, which had maintained the landscape for thousands of years, were suppressed, changing fire patterns and plant communities. And then came the predators, foxes and cats, introduced from Europe. These efficient hunters found the pig-footed bandicoot easy prey. The last confirmed specimen was collected in 1907. There were a few possible sightings after that, but nothing definite. By the 1950s, it was almost certainly extinct. The desert rat kangaroo appeared in large numbers after heavy rains. This small marsupial, about the size of a rabbit, lived in the arid center of Australia. It had the ability to survive in incredibly harsh conditions, going long periods without water. After rain brought desert blooms, populations would boom, with the animals appearing in large numbers to take advantage of the sudden abundance of food. But during droughts, they would become scarce, retreating to the most favorable areas. Extended drought and predators caused its disappearance. The late 1800s and early 1900s saw several severe droughts in central Australia. At the same time, introduced foxes and cats were spreading across the continent. The desert rat kangaroo, which had evolved with few predators, had no defense against these efficient hunters. The last confirmed sighting was in 1935 from a location in central Australia. After that, nothing. Extensive searches in subsequent decades found no trace. Across the Tasman Sea, New Zealand faced its own extinctions. The laughing owl vanished after forest clearing and predation. This owl had a distinctive call, a series of loud, dismal shrieks and weird chuckling notes that gave it its name. Maori called it weka and said its cry was an omen. It was a fairly large owl, tawny brown with streaks and spots, with powerful talons for catching prey, as large as young rabbits and birds. European settlement brought massive forest clearing to New Zealand. The owl's hunting grounds disappeared. Rats, stoats, and cats were introduced, eating the same prey the owls depended on, and likely killing owl chicks in their ground nests. The last confirmed wild specimen was found dead in 1914, though there were occasional unconfirmed reports until the 1930s. The laughing owl's eerie calls, once common in the New Zealand night, fell silent. The North Island piopio disappeared in the early 1900s. The piopio were thrush-like birds, known for their beautiful, melodious songs. The North Island species was slightly larger than its South Island relative, with rich brown plumage and a distinctive white flash in its tail. It lived in native forests, feeding on insects and fruit, hopping along branches and occasionally dropping to the forest floor to forage in leaf litter. As forests were cleared for farming, piopio habitat shrank. Ship rats and stoats, introduced to control rabbit populations, found piopio nests easy targets. The birds, which had evolved without mammalian predators, had no defensive behaviors to protect themselves or their young. The last confirmed sighting was in 1902, though there were scattered uncertain reports for a few years after. By 1910, the North Island piopio was effectively extinct. And then there's one of the saddest stories in all of extinction history. The Stevens Island wren was wiped out largely by introduced cats. Stevens Island is a small rocky island in the Cook Strait between New Zealand's North and South Islands. In 1894, a lighthouse was built there, and the lighthouse keeper brought his cat. That cat, named Tibbles, began catching strange little birds and bringing them back to the lighthouse. The lighthouse keeper, curious, sent some specimens to ornithologists. Scientists realized these were a species unknown to science, a tiny, almost flightless wren found nowhere else. before they could even properly study it, the birds were gone. Tibbles and other cats on the island hunted them to extinction within just a year or two. By 1895, the Stevens Island wren was extinct. One cat, or a small number of cats, eliminated an entire species that had evolved in isolation for potentially millions of years. It's often said that Tibbles alone killed them all, though the reality was probably slightly more complex, with multiple cats involved. But the basic tragedy remains: a unique species, discovered and destroyed almost simultaneously. Australia and New Zealand, once sanctuaries of unique life, suffered terribly from the introduction of mammals to islands that had evolved without them, marsupials that had no concept of dogs, cats, or foxes, birds that nested on the ground because there were no mammals to raid their nests, ecosystems built over millions of years, unraveled in decades. Rest now. Breathe slowly and deeply. These southern lands are still beautiful, still wild in places, but they're emptier than they once were. The Thylacine no longer pads through Tasmanian forest. The pig-footed bandicoot no longer races across arid plains. The laughing owl no longer calls in the New Zealand night. The Stevens Island wren no longer flits through coastal scrub. Each loss is permanent, each voice silenced forever. Let sleep come gently, carrying you on its quiet tide. We move forward now, closer to the present day. These aren't ancient stories from centuries past. These are extinctions that happened in your lifetime, or your parents' lifetime. Losses, witnessed by people still living, documented with cameras and recording equipment, studied by scientists who desperately tried to prevent them, and yet they happened anyway. The dusky seaside sparrow disappeared after wetlands were drained and pesticides were used. This small bird lived only in the salt marshes of Florida's Atlantic coast, particularly around Merritt Island and the St. Johns River. It was a subspecies of the seaside sparrow, darker than its relatives, with heavily streaked plumage that helped it blend into the marsh grasses. It built its nests low in the vegetation, just above the high tide line, woven carefully from marsh grass and lined with finer materials. In the 1950s and 60s, marshes where the sparrows lived were flooded to control mosquitoes, part of an effort to make the area more hospitable for the growing human population and for NASA's Kennedy Space Center. The flooding killed the marsh grasses the sparrows needed. Later, highway construction drained other marshes. Pesticides sprayed to kill mosquitoes also killed the insects the sparrows fed on. The population declined rapidly. The last individual, nicknamed Orange Band, died in 1987. Orange Band was a male, the last of 5 males that were captured in a desperate attempt to save the subspecies through captive breeding. But there were no females left to breed with. Scientists tried crossing the males with females of other seaside sparrow subspecies, hoping to at least preserve some of the dusky seaside sparrow's genes. But it wasn't the same. Orange Band lived out his final years at Walt Disney World's Discovery Island, dying on June 17, 1987. The dusky seaside sparrow, a unique form of life shaped by Florida's marshes over thousands of years, was gone. Across the Atlantic, in the mountains between France and Spain, another ending approached. The Pyrenean ibex went extinct in 2000. This was a subspecies of Spanish ibex, a wild goat with magnificent curved horns that lived in the Pyrenees mountains. It was hunted for sport and trophies for centuries. But the population survived in remote mountain areas. By the 20th century, only a small population remained in the Ordesa Valley in Spain. Conservation efforts came too late. The last individual, a female named Celia, was found dead on January 6, 2000, killed by a falling tree. She was the last of her kind, the end of a lineage that had survived ice ages and climate shifts, but couldn't survive human hunting pressure and habitat loss. But the story doesn't quite end there. Scientists cloned it in 2003. Before Celia died, researchers had taken tissue samples and frozen them. Using these samples, they attempted to bring the Pyrenean ibex back from extinction through cloning. They created embryos by inserting Celia's DNA into eggs from domestic goats, then implanted these embryos into surrogate mothers. Most attempts failed, but one succeeded. In July 2003, a cloned Pyrenean ibex was born. The cloned ibex died minutes after birth due to lung defects. The little kid gasped for breath. Its lungs malformed her, unable to get enough oxygen. It died 7 minutes after being born, the only member of an extinct species to be brought back, however briefly, and then lost again. The Pyrenean ibex has the distinction of being the only species to go extinct twice. It was a glimpse of what might be possible with cloning technology, but also a reminder of how difficult and uncertain that path is. Meanwhile, a different kind of threat was spreading across the world's amphibian populations. Chytrid fungus has devastated amphibian populations worldwide. This fungal disease, caused by Batrachochytrium dendrobatitis, infects the skin of frogs, toads, and salamanders. Since amphibians breathe partly through their skin, the infection disrupts their ability to absorb oxygen and regulate water and electrolytes. Infected amphibians often die within weeks. The fungus appears to have originated in Asia and spread globally through the international wildlife trade, hitching rides on infected animals being shipped around the world. It thrives in cool, moist environments, exactly where many amphibians live. Once it reaches an area, it can devastate populations with terrifying speed. Scientists estimate chytrid fungus has caused the decline or extinction of over 200 amphibian species, making it possibly the most destructive disease for wildlife ever recorded. The Chiriqui harlequin frog disappeared after 1996. This small, brightly colored frog lived in the cloud forests of Costa Rica and Panama. Males were a brilliant orange or yellow, while females were black with red or orange markings. They lived along mountain streams, sitting on rocks in the spray, feeding on small insects. They were once common, easy to spot because of their bright colors and their habit of being active during the day. Then chytrid fungus arrived. Within a few years, the frogs were gone. Surveys that had found hundreds of individuals suddenly found none. The last confirmed sighting was in 1996 in Costa Rica. The species is considered critically endangered, possibly extinct. There's a slim hope that a population might survive somewhere in the remote mountains, but years of searching have found nothing. The mountain streams still flow, still create their mist and spray, but the bright little frogs that once decorated the rocks are gone. The splendid poison frog vanished by the early 2000s. This tiny frog, barely over an inch long, lived in a small area of western Panama. It was spectacularly beautiful, bright red or orange with dark limbs. One of the most colourful of all poison frogs. Like other poison frogs, it got its toxins from the insects it ate, making it unpalatable to predators. Its bright colours warned potential predators to stay away. It was discovered by science only in 1992, and by 2004, it was gone. Chytrid fungus swept through its habitat. Researchers watched helplessly as populations crashed. The last individual seen in the wild was in 2004. Captive breeding attempts failed. The splendid poison frog, discovered and lost within a single human generation, known to science for just 12 years before it disappeared. In Tanzania, another small creature faced disaster. The Kihansi spray toad went extinct in the wild after a dam-altered water flow. This tiny toad, less than an inch long, lived only in the spray. Zone of the Kihansi Falls, a small area of perhaps 2,000 square meters. The toads had evolved to live nowhere else, perfectly adapted to the constant mist and spray from the waterfall. In 2000, a hydroelectric dam was completed upstream. The dam diverted most of the water flow, dramatically reducing the spray and mist that the toads depended on. Their habitat dried out. The population crashed. By 2004, extensive surveys found no toads remaining in the wild. Fortunately, some individuals had been taken into captivity before the wild population disappeared, and captive breeding was successful. Thousands of Kihansi spray toads were later reintroduced to the spray zone after a sprinkler system was installed to artificially recreate the mist. They're back in their original habitat now, but they're functionally a managed population, entirely dependent on human intervention to survive. Disease has become a major modern driver of extinction, not just chytrid fungus, but many diseases. White nose syndrome killing bats, avian malaria devastating Hawaiian birds, facial tumor disease threatening Tasmanian devils. As humans move around the globe, we inadvertently move pathogens with us, introducing diseases to populations that have no immunity, no evolutionary experience with these threats. Combined with habitat loss, climate change and pollution, disease can be the final blow that pushes a struggling species into extinction. These modern extinctions feel different, don't they? They're not ancient history. They're recent enough that we have photographs, video footage, recorded calls. We know exactly what we lost. We can watch the last dusky seaside sparrow on film. We have tissue samples from the last Pyrenean ibex frozen in laboratories. We have detailed field notes from researchers who watched frog populations collapse in real time. The losses are immediate, vivid, undeniable. Breathe slowly now. Let your body relax completely. These stories are heavy because they're so recent, so preventable, so final. Orange band dying alone in his enclosure. The cloned ibex gasping for 7 minutes. The bright harlequin frogs vanishing from their streams. All within living memory. All documented. All irreversible. Rest now and let these thoughts settle gently as you drift deeper into sleep. The world continues to turn, but it's different than it was just decades ago. Quieter, less colourful, missing voices that can never speak again. As we near the end of our journey through these quiet histories, we come to the loneliest stories of all. Stories of lost individuals, the final representatives of their kind, living out their days knowing, perhaps in some way, that they are utterly alone. Lonesome George was the last Pinta Island tortoise of his subspecies. He was found in 1971 on Pinta Island in the Galapagos, a lone male wandering the volcanic slopes where thousands of his kind once lived. Scientists brought him to the Charles Darwin Research Station on Santa Cruz Island, hoping desperately to find him a mate. They searched Pinta Island thoroughly. They offered rewards for information. They checked museums and zoos around the world, hoping someone had collected a female decades earlier. They found nothing. For years, George lived with female tortoises from similar subspecies, hoping he might breed with them and at least preserve some of his unique genes. But George showed little interest. On the rare occasions when he did mate, the eggs proved infertile. Scientists tried various techniques, adjusting his environment, his diet, his companions. Nothing worked. He died in 2012 after decades of failed breeding attempts. On June 24, 2012, his caretaker found him dead in his enclosure. He was probably over 100 years old, possibly older. With George's death, the Pinta Island tortoise subspecies became extinct. He had been alone for over 40 years, the last of his kind, a living symbol of extinction. His body was preserved and now resides in the Galapagos, a memorial to what was lost. But George wasn't the only lonely one. The Hawaiian tree snail, Achatinella apex fulva, lost its last individual in 2019. This was a tiny snail, barely the size of your thumbnail, with a beautifully patterned shell in shades of brown, white, and yellow. It lived only in the mountains of Oahu, in native Hawaiian forests. These snails were incredibly slow living. They took years to reach maturity and could live for decades, slowly crawling along tree branches, feeding on fungus growing on leaves. The last individual, named George as well, in honor of Lonesome George, lived at the University of Hawaii's Snail Lab. Scientists had been keeping a small population alive, hoping to breed them, but the snails reproduced so slowly that the population couldn't sustain itself. One by one, they died. George was the last. When he died on New Year's Day, 2019, at the estimated age of 14, the species went extinct. A species that had evolved over millions of years, that had survived countless natural challenges, gone because of habitat loss, introduced predators, and the simple mathematics of small populations. In the forests of Maui, another ending played out. The Pōuli, a Hawaiian forest bird, vanished in 2004. This small honey creeper was discovered only in 1973, found in remote mountain forests on Maui. It had dark plumage with a distinctive white rump and a black face mask. It fed on insects and snails, hopping through the understory vegetation, probing bark and leaves. By the time scientists realized it existed, it was already rare. Habitat loss, introduced predators like rats and cats, and avian diseases carried by introduced mosquitoes had devastated its population. By the late 1990s, only a handful remained, scattered across the forest. The last 3 Pōuli failed to find mates. 3 individuals were known to exist in the early 2000s, but they lived in separate territories, apparently unable or unwilling to find each other in the dense forest. Scientists tried to capture them to bring them together for captive breeding. They caught one male in 2004, but he died in captivity shortly after, apparently from stress and malaria. The other two were never seen again. By 2004, the Paleontology was extinct. 3 birds, the last of their species, unable to connect, dying alone in separate valleys. Not all stories end in complete extinction, though. Some species are classified as extinct in the wild, but survive in captivity. This is a strange kind of existence, neither fully extinct nor fully surviving. These animals exist only because humans have taken them into zoos and breeding facilities, maintaining small populations through careful management. Père David's deer disappeared from the wild in China in the 20th century. This deer, named after the French missionary and naturalist who described it, once lived in marshlands in northern China. By the time Europeans encountered it, it survived only in the emperor's hunting park near Beijing. It was already extinct in the wild, wiped out by hunting and habitat loss. Centuries earlier, in the late 1800s, European zoos acquired some individuals. This proved fortunate, because in 1900, floods destroyed the walls of the imperial hunting park, and the remaining deer escaped, only to be killed by starving peasants during the Boxer Rebellion. The species was extinct in China, but the animals in European zoos survived and bred. Eventually, their descendants were reintroduced to China. Today, there are small populations living in protected reserves, but they're still essentially a managed species, dependent on human care. They survived extinction, barely, but they lost their wild existence. Scientists use museum specimens to study DNA from extinct animals. In drawers and cabinets in museums around the world rest the physical remains of extinct species. Preserved skins, mounted skeletons, specimens in jars of alcohol, carefully labeled and catalogued. For decades, these were simply reference materials, ways to study anatomy and identify species. But modern genetic technology has given them new importance. Scientists can now extract DNA from old specimens, even from animals that died over a century ago. They can sequence genomes, understand genetic diversity, trace evolutionary relationships. They've extracted DNA from museum specimens of passenger pigeons, Thylacines, great auks, and dozens of other extinct species. This genetic information tells us things we could never learn just from looking at bones and feathers. This research helps protect their closest living relatives. By understanding the genetics of extinct species, scientists can better understand the species that remain. They can identify genetic weaknesses, understand how populations respond to environmental stress, and develop better conservation strategies. The extinct animals, through their preserved DNA, continue to teach us, even though they're gone. And this brings us to the final thought, the reason all these stories matter. The story of extinct animals is not just about the past. It is a warning for the future. Every animal we've discussed tonight, from the Diprotodon to the Paleontology, existed for thousands or millions of years before disappearing. Often within decades of encountering human civilization, the pattern is undeniable. The message is clear. We live in a time of unprecedented extinction. Scientists call it the 6th mass extinction. The first one caused not by asteroids or volcanic eruptions or climate shifts beyond anyone's control, but by us. by human activity, by our choices about how we use land, how we harvest resources, what we consume, what we value. But unlike past extinctions, we have the knowledge and the power to change course. We understand what's happening. We can see the patterns. We have the technology and the resources to protect what remains. The question is whether we will, whether we'll learn from these stories of loss, or whether future generations will tell stories about animals disappearing in our time, in this decade, this year. The elephant birds will never stride across Madagascar again. The great auks will never swim in the North Atlantic. The thylacines will never hunt in Tasmanian forests. These losses are permanent, irreversible, final. But other species, hundreds of them, thousands of them, still exist, still struggle, still have a chance if we make different choices than the ones that led to all these extinctions. Rest now, deeply and completely. Let these stories settle in your mind like sediment layers, recording what has been lost, remembering what existed, honoring the vanished creatures who once shared this world with us. The night is quiet around you. The extinct animals are silent now, but their memory speaks. Their absence teaches. Their loss warns. Sleep peacefully. And when you wake, remember them. Remember what we've lost. And remember what we still have a chance to save. The story isn't over yet. The future is still being written. And unlike the animals we've remembered tonight, we still have time. Good night.